From the Library of Congress in Washington, D.C.
So good morning, I'm Jennifer Harpster, a research specialist in the Science, Technology, and Business Division at the Library of Congress. I'd like to welcome you to today's program, Mapping the Moon with WALL-E and Children. This program will demonstrate how NASA has employed WALL-E, the title character in the 2008 computer animated film from Pixar Studios, into its digital learning network. This program is the fifth in a series in 2011, presented through a partnership between the NASA Goddard Space Flight Center and our division. This is our fifth year presenting programs with Goddard. Our speaker today, Dr. Marcianna Delaney, has led several of NASA's educational outreach projects with the Digital Learning Network, the Exploring Challenges series, and the e-Education Product Showcase series. She has served as a team leader of Goddard's Learning Technology Group and developed an agency-wide project for K-12 academic competitions, for which she received a NASA Special Services Award. She began her career as a biological oceanographer, receiving a bachelor's in marine biology from the University of North Carolina at Wilmington, and a master's and doctorate degrees in biological oceanography at Memorial University of Newfoundland. She recently left NASA and moved to Maine to teach at the University of New England. We graciously thank Dr. Delaney, who has traveled down from the Pine Tree State, today to demonstrate NASA's Digital Learning Network and how WALL-E introduces students and educators to NASA's newest missions and its efforts to return to the moon. So please join me in welcoming Dr. Delaney.
Okay, thank you everyone. So now that I realize that we've had so many children come in, which is wonderful to see, I've completely changed up what I was going to talk about. But I promise kids, I do have to do a little, make my money worth my while here today. So I have to talk to your adults first, and then I promise I'll take care of you guys next. How's that? Okay, so NASA, often lots of people think NASA spends lots of money. We have all these missions. Where's our tax dollars going? Blah, blah, blah. But one thing that's often overlooked is that NASA has a huge education program. In fact, it is one of the only agencies that has education as a separate entity within the agency. FDA may have a department or something, but an entire Office of Education does exist within NASA across all 12 centers. And in the recent years, I'd say in the last 10 years, as technology has developed, part of NASA Education's projects has included the use of educational technologies, and part of that is the Digital Learning Network. Now, I am a user of the DLN here at Goddard. I am not the project manager of that originated out of Langley Research Center. But what it's done is that it has brought high-end video conferencing from NASA to our schools. Your tax dollars at work, because we still provide free programming to K through 12 and sometimes even undergrad and graduate students as well, across the country, sometimes in places across the world. About 5 years ago, though, Goddard kind of changed how things happen with the DLN and how we can really bring more energy into our video conferencing events. We have a catalog. Teachers get to pick what they want, what kind of content they want covered. We provide a class module that fits a 45-minute or so kind of thing. And it's often what people do with video conferencing, because video conferencing is becoming more and more available, and more of the use of what teachers need to supplement what they're already teaching. Because the kids of today, as you well know, love multimedia. And how can we get them to listen to what's happening to the teacher when you go beyond the classroom walls? So about 5 years ago, we had an awesome opportunity, something that started out with a graphic animator at Goddard Space Flight Center. So yes, kids, we do have people who draw cartoons that work at NASA, was at a conference. Alex Kekasi was at a conference of other animators, and he started chatting it up with a Pixar animator. And at that time, actually it's been probably more than 5 years ago now, is when Pixar was just drafting up WALL-E, the movie WALL-E. No one knew really anything about it except for that same little promo everyone saw for the movie beforehand, when it was just the Pixar producer sitting at the lunchtime cafe talking about their ideas. That's all anybody knew. That's all anybody of the public knew about what was going to be the next big thing for Pixar. Well, they found out a little bit more in that it was going to be about a robot, and that they based that robot, the look and feel of WALL-E, on the Mars rovers. Do you guys know the names of the 2 Mars rovers? Spirit and Opportunity. So more and more we hear this, and then there was this big rush, and everyone thought, oh, wouldn't it be great if Pixar and NASA could partner up some way? So somehow it got onto my desk. I don't know how, but I was flattered, and I had to draft up a proposal of how could we use WALL-E for NASA education. So we came up with a bunch of ideas, and the biggest one was, could we bring WALL-E into video conferencing? Kids love to watch movies. Kids love cartoons. We have green screen technology. We're not utilizing it enough. Could we do this? Could we get away with doing this through just video conferencing, where kids could interact with the robot? So off we flew to the West Coast. Got a lovely tour of Pixar Studios, which, by the way, if anybody ever wanted to work for an awesome place, that is an awesome place. And we pitched our proposal. A team of us, we had a bunch of ideas, and one of them was that of mine with using the digital learning network. Pixar accepted it, and then became the start of a year-long relationship of what we could and could not use WALL-E for. And I think in this picture, what I wanted to start with was just this picture alone to show you it was a long relationship in getting this out to the public. But I think right then and there tells you it was worth all the while. The number of children who have been affected by bringing WALL-E into the classroom, they all want to participate. And I think you guys, for the adults in this room, you'll see that soon when I do the activity with your students here. So we had created a module. Pixar did not create anything for us custom made. They gave us what they would give any media packet, what you normally pay for. But again, we do have animators that work for NASA. And they were able, or particularly one individual, Chris Smith, God bless his soul, spent the hours and hours and hours taking these snippets and working with me and my team in how can we make these snippets work with the stuff we need to teach, the content we need to get the point across. We had chosen at the time, this was 5 years ago or so, the newest mission that was on the docket at Goddard Space Flight Center was the Lunar Reconnaissance Orbiter. And so we decided to match the content with that. And afterwards, Andrea Jones here can give you a little bit more information about the moon. LRO is, of course, now coming to the end of its mission, but it was on the top of her mind, and students often didn't know that NASA did a lot more than just sending astronauts into space. So we decided to do that. We spent multiple hours, and we tried to create as many products out of what we had so that would be worth our while, be worth the public's while, and stay available free for as long as we could. So what we got out of it was 3 products. We got to make a little promo. Actually, that's not one of the products, but we made the promo. We created 2 video conferencing modules, one for K to 3 students and one for 5 to 8, and incorporated more content, of course, and higher level understanding for the 5 to 8. It required hands-on activities. It required interaction. The students got to talk back to us through the video conferencing. We got to see them. We got to see the reaction. And we created an archivable piece that even up to college, I know a college professor who wanted to use this because his students didn't understand ratios. So let me show you first what got everyone signing up and crazy about this module. So again, this is available free to the public, to the schools, if they have the video conferencing equipment, that they could sign up for these modules, as well as 50 other modules that the DLN provides. This one, however, in the first year, we surpassed any module that had ever existed before within just the first school year of it being out. We were turning teachers away because it was just became so popular. It was something different. It wasn't just the presenter in front of a PowerPoint presenting to the students. Yes, of course, we always encourage interactivity with students in our presentations, but this is the first time NASA DLN got to bring in an active character and get the students to respond in even more because of that character. And in fact, it was such a success that the same individual who helped us with this, Chris Smith, who's our animator, created another character for another mission at Goddard, the Solar Dynamic Observatory. He created little SDO, a little animated SDO, and we were able to do an entire in-house production of interacting with a little SDO to teach about that mission. So it's turned to be a very successful way of getting children's attention, and I don't think anybody could argue with me about how a Disney character is going to definitely get your kids to stay glued and listen, and they will walk away remembering that information, which I hope we can get a chance to see today. So the other archive piece I was talking about that we have available, that again, we wanted to make sure we had something that was live and interactive, but also freely downloadable, that they could use for short lesson moments. And I will explain about the pieces of what we got from Pixar.
NASA Education, Wally, take one, and, whoa, hey, Wally, we're not ready. You're not on yet. Whoa.
Guys, are we ready? Hello?
So I see you've met our special guest. Thanks, Wally. NASA's put people on the moon before, and the Lunar Reconnaissance Orbiter is mapping the moon so that we can go back. Now, when you've looked at the moon from your backyard, it looks really tiny. So how does NASA put a spacecraft on something so small? Well, that's because it's probably not as small as it looks. So the question of the day is, how big is the moon? And to answer that, we need to apply a proportion. That's right, Wally. A proportion is the relationship between things, such as the relationship between the size of the Earth and the size of the moon. To find the actual diameter of the moon, we can use two everyday objects to represent the relative sizes of the Earth and the moon. Great idea, guys. A baseball is just about the right size for our moon. Now we need an Earth. Ooh, a basketball. Perfect. Wait, don't. Thanks, Wally. So we could use the basketball as our Earth and the baseball as our moon. Now a basketball is 24 centimeters in diameter and the baseball is 7.5 centimeters in diameter. So let's apply our proportion. Baseball over basketball equals x, because that's what we're trying to find out, over the Earth's diameter. And we know that because we live here. So that's 12,756 kilometers. Now, cross multiply and solve for x. So we just solved that the moon's diameter is about 3,900 kilometers, but you should check to see if we're right. In any case, the moon's plenty big to land a spacecraft, to live and work on the moon in the future. To learn more, check out www.nasa.gov.
So like I said, all those little pieces of those animation clips were not custom made to us. We had to find the content to fit that animation. And we got very clever, as you could see, with the baseball and the basketball thing. Oh, you don't need to see that I'm having my Library of Congress talk. And so we were very lucky in doing that, and we had actually quite a big set of animations to work with, which helped us then create the video conferencing modules. So without further ado, I thought I would go ahead, since we have so many children in the audience, that we would do the younger version of the module, and you guys can see for yourselves how well your children will learn. And just be patient, because I've never done it this way. I'm always on a green screen in a very small studio. Okay. to make sure everybody can hear. And if I'm not loud enough, you'll let me know, right? So you'll have to remember that this is usually in front of a camera. Some of the clips you just saw in the promo and the other video were used for this. So I'm going to have to kind of wing it a little bit. And hopefully my play pause will work. No, wait, don't, no, Wally. What am I supposed to do now? Hello? Let's see if it paused. Did it pause? Okay, great. Oh, are we on? Okay, we're good. Well, hello, everybody. How are you today? Hi. Good, great. And where are you guys from? You want to tell me? Sorry, where?
Reston, Virginia.
Reston, that's right. And I heard earlier this one had just moved here. How about you? Where are you from? Do you know what town you live in? No? How about the friends who are just joining us? Where are you guys coming from?
We're coming from DC.
DC, all right. Well, my name's Dr. Marcianna Delaney, and I am here to talk to you guys about some of the great things happening at NASA these days that, you know, I'm not so sure you know of what things are going on. And goodness gracious me. But, you know, we really need to, but obviously, I think somebody else wants some attention here. So let's give him a proper introduction, everyone. So Wally, come on out. Don't be shy. Don't look there. Go look at the audience. Wave to them. Thank you. Everybody can wave to Wally if you want. So Wally actually came to join us today to share with you guys some of these great things that happen at NASA. And, you know, I did see earlier that he had some pictures that he wanted to share with you. So I hope you guys can help me identify what those pictures are. So Wally, come on out and show us what your first picture is for the students. Oh, come on. Don't be shy. Is it working? There we go. Oh, right. What is this a picture of, boys and girls? It is an astronaut. And what do you know about astronauts? They do go to space. That's right. Anything else?
They're from Earth.
That's right. Our astronauts are absolutely from Earth. What else would you like to share?
And they go in rockets to go to the moon.
Well, not all of them go in rockets, but yeah. A long time ago, we did have some astronauts go to the moon, but we haven't had any astronauts lately. What else did you want to add?
They live in a space station.
There are some that live in a space station right now. That's right. Okay, well, Wally, how about another picture for our students today? Now what is this a picture of, boys and girls?
Rocket.
Now, it's not quite an airplane. It's actually a very special vehicle.
A jet.
It's kind of a combination of a jet and a space. It's the Space Shuttle. That's right. It's the NASA Space Shuttle Orbiter, which just retired, by the way. But I said it's not quite a plane. It has some same characteristics of a plane or a jet and a rocket ship because it takes off from Earth like a rocket, but like you see in this picture, it lands like an airplane. Now, what does this picture have to do with the first picture?
Because the astronauts actually ride in that.
That's right. It is the main vehicle of transportation until recently for our astronauts. It is how they got outside of Earth's atmosphere. But we've just recently retired the Space Shuttle. Did you guys know that? And do you know why we had to retire the Space Shuttle? Well, maybe.
Sometimes they explode.
Well, unfortunately, we've had two very unfortunate accidents, right? But you know what? They're really old. Think about the car you're driving in. Your car's not from 1979, is it? No. The Space Shuttle, the first Space Shuttle is from 1979. It is getting too old to repair and too expensive. So we're now building new spacecraft to get to space. All right, Wally, what's our next picture? Oh, I think you all know what what's this a picture of, boys and girls? Shout it out. Earth, that's right. And what makes Earth so special? It's the Earth, but what makes Earth so special? Go ahead. Okay, because we have lots of who believe in them.
a breathable atmosphere?
We have, oh, that's a great word. We have an atmosphere, a very unique atmosphere. And because of that atmosphere, we have what on this planet?
The moon.
How about you in the back? What is on this planet? Because we have, I'm sorry?
People.
People, that's right. We have people, we have animals, we have plants. Because of this unique atmosphere and what? What's all that blue stuff, boys and girls? Water. 3/4 of our planet is covered with water. And that makes us so unique. All right, Wally, how about another picture? I think they got this one. All right, everybody. Now, what is this picture, young man? It's the moon. That's right. And what do you know about the moon?
That it has moon rocks?
Absolutely. Absolutely. How about, okay, in the green again? Or blue and green, yeah?
It's really light that astronauts sometimes go there.
Well, they haven't been there in a long, long time, but we'll get back to that. How about our children who are sitting on the steps? Do you guys know what the circles are on the moon? They're called? What?
The holes inside the moon.
Are called craters. The moon is covered in craters. So, what does the moon not have that Earth does? What do we just say is a big word? Yeah. That, well, we're getting to that. Hold on, hold that thought. Something else. Starts with the A, the big word. Atmosphere, right. The moon has no atmosphere. So remember that, everybody, because I'm going to ask for it again. All right, Wally, do we have any other pictures for our students today? All right, boys and girls, what is this? It's the sun. Is the sun a planet? No. What is it? Everybody. It's a star. And what does this star give to us here on Earth? Light and heat. And do you know one more thing that it's giving off that actually why we wear sunscreen?
Because we get sunburned.
Why do we get sunburn? What is that called? What's coming off the sun and to us here on Earth? Go ahead. The UV rays, right. So one thing you got to remember is that while the sun gives us that wonderful light and heat, should you ever look at the sun with your naked eyes? No. Make sure, can you look at a sun with just your sunglasses? No. It's very dangerous because of those UV rays. So just think, there's those three things coming off the sun: heat, light, and UV rays. Okay, Wally, well, I think I understand now what Wally's trying to show us. He's trying to show us that there's so much more going on at NASA than just sending the astronauts into space. We have scientists at NASA that study the Earth, the moon, the sun, and beyond, all these things. That is the bulk of the work that goes on at NASA, is the science. But for a scientist to do his or her job, they need the help of another individual called an engineer. Do you guys know what an engineer does? How about this gentleman here in the blue shirt? Do you know what an engineer is? Go ahead and guess. Does anybody want to help him? You're very active today. What do you have to join?
An engineer is basically like someone who fixes things or creates.
That's right. Engineers help build, repair, design, build, and repair, and in the case for NASA, our spacecraft. So they're the ones who take the idea from the scientists and create those spacecraft that help us study those things. They have to work together. So here's an example of a NASA spacecraft that our engineers, near and dear to our heart at Goddard Space Flight Center. Oh, and I just lost my picture. Can I get it back? Let's see. Oh, no! Hold on. We're going to have to do a little, I told you this was going to, I've never done this before. Let's go mute. Yep. There we go. Okay. All right, so does anybody know what this is a picture of? It is a satellite, and this satellite has a very special name. Does anybody know what that special name is?
It's gone.
I know it's gone. I'm not going to try and get it back again. It's the Hubble Space Telescope. The Hubble Space Telescope was built by NASA's engineers, designed, built, and in fact even repaired, because our astronauts went there a few years ago to help repair the Hubble Space Telescope, for our scientists to make amazing discoveries of deep space, like the one you just saw that went poof, back on gone, the Eagle Nebula. So without our scientists and engineers working together, we can accomplish all these missions going on at NASA. So what we're going to talk about today is another mission. It's actually now coming to its end, but it was to help us explore something even more. But before I say any more, I think we should watch a little film that gives us a kind of a backdrop for it. So Wally, do you have that? And let's, oh, okay, I'll get out of your way.
We leave as we came, and God willing, as we shall return. We shall return. We shall return. Three. Sight. Two. Sight. One.
So did you guys like that? Yeah? Who, by show of hands, who would like to go to the moon? Okay, those of you who are my age or older, put them down, because we're already too old. But all of you, our young friends, may have that opportunity to go to the moon. By the time you get out of college or graduate school, you may have that opportunity to build and work on a research community on the moon. Now, NASA's changed some of its priorities, but there's still a sense of exploration, because we have not had a human on the moon since 1972. Were any of you born in 1972? And no one else has to admit their age, really. No, but things have changed so much since the last time we had a human on the moon. Do you guys know what kind of phones we used to use in 1972? Did you ever see a rotary phone? Do you even know what I mean when I call a rotary phone? It was a big box attached to the wall that you had to turn a dial to make a phone call. Now, what do you guys carry around and use of your mom and dad's? Oh, stop. You know everything. How about someone I haven't heard from over here? The cell phone. And that cell phone's only about this big now. Some are even as big as my little remote here. That shows you how much technology has changed over these 38 some years. And that's why we'd like to go back to the moon to further investigate what's there. But before we can send humans to the moon, we had to develop a mission that we could do robotically to take a look at other things. And that mission was called the Lunar Reconnaissance Orbiter, or like NASA likes its acronyms, LRO, because we try to keep everything short, just like NASA's a short acronym. But let me just quickly go over it with you kids. So L, lunar, is just simply another word describing, what are we going to look at? The moon. R, reconnaissance. That's a big word. Do any of you know what reconnaissance means? Anybody have one of those video games, spy games? It means to look into something deeper, to investigate, reconnaissance. You're going to go find out information. And O, orbiter, is meaning that this spacecraft is orbiting the moon. It's not going to land on the moon like you think the Mars rovers did. It's going to orbit the moon. So LRO had a couple major objectives to accomplish, which mostly have finished, and Andrea can help finish on this statement. But one of them is to help us, well, something has something to do with this picture here. What is this a picture of, boys and girls?
United States.
It is a picture of North America because it's got United States, a bit of Canada and Mexico. But what is it a special picture of? This type of picture is what? A map. That's right. It is a map. Now, what's so different about this map? What's all this brown rumply stuff here? How about someone I haven't heard from? This gentleman in the gray t-shirt. What's all this brown rumply stuff?
Mountains.
Mountains. And there's a little bit of mountains over by us, the Appalachians Mountains. But are there mountains in the front, in the center of the continent, or North America? Are there mountains here, boys and girls? No, because it's what? Flat. Does anybody know what that kind of area is called? Yeah?
The plane.
The plains. So really, this is a map that's showing us the different elevations of North America. Wally, I wasn't done with that yet. Okay, where was I? Right. It was a map showing us the different elevations of the surface, showing us the high points and the low points. Well, that's what LRO is going to do, is help us collect data about the moon so that we can create a map of those different elevations. All right? So, there is another objective of LRO with its sister counterpart, LCROSS, that we're looking for something on the moon. But you know what? Wally's got a clue for you. So, Wally, what are we looking for on the moon? Oh, wait, no, don't do it. Please. Yeah, no. Oh. Turn it off, please. No. Now, if I was on camera, I'd get away with saying, oh, go get a mop, please, clean it up. Anyway, what was the clue, boys and girls? What are we looking for on the moon? Everybody. Water. We're going to be looking for water. Because if you are going to be the generation that's going to live and work on the moon, you're going to need water to survive. Now, you guys have you ever had to do some chores around the house where you had to fill a bucket with water, like wash the car? Now, when you fill that bucket all the way to the top, is it heavy or light? Heavy. That's because water has a lot of mass to it. So can you imagine if we had to take thousands and thousands of buckets of water from the Earth to the moon? No, it'd be very difficult to do, very expensive to do. So if we can find evidence of water on the moon, then maybe we won't have to bring so much when we build our research community. So the last question of the day would be, where are we going to look for water on the moon? And Wally has one more clue for you, I think. Oh, he is so silly, you know, and that's a really tough clue. I think he's trying to tell us, what does the moon have in common with a magnet, actually? What does it have in common?
No gravity.
No, there actually is gravity on the moon. 1/6 gravity is on the moon. What do you have? What's your idea?
I think that is because it's like another magnet. So it's like it has the north and the south, and it has.
Well, let's look at that. What is that word, boys and girls? Where do we find polar bears? In the north? Where do we find penguins? South Pole, right. A magnet has a north and a south pole. The Earth has a north and a south pole. Well, so does the moon have a north and a south pole. And I'm trying to get my thing to go. Hold on. Patience, please. There we go. Thank you, Wally. So the moon has a north and a south pole. Now, when you think of the south pole of Earth, what state of matter is water mostly in? Ice. It's a solid. That's right. It is so cold down in the south pole of Earth that the water is frozen as ice. Well, guess what? On the moon, the north and the south pole, we are looking in they are permanently shadowed regions of the moon. That's a big term, but basically what it means is the sun doesn't shine on parts of the poles of the moon. Because think about it, if the sun did shine, we're looking for water, everybody, and we're looking for water ice. If the sun did shine on that ice, what happens to the ice? It melts. And if the sun keeps shining on that ice, or on that melted water, then what happens to water when it heats up? It evaporates. What does the moon not have, boys and girls? No, what does it not have, what we said earlier today? Has no atmosphere. So if there was water that was being exposed to the sun and it evaporated, there's no atmosphere to hold it in, so it would just disappear off into space and we would never be able to find evidence of water on the moon. So we're looking in the permanently shadowed regions, the dark regions of the moon, for that water ice. And we actually had a mission go along with LRO called LCROSS that did something really cool. It sent out an impactor, like a kind of a big explosion, or impactor, I'm losing my words now, torpedo to the surface of the moon, hit the surface of the moon, boom, create a huge explosion. We made our own crater on the moon, and all that material that flew up from that explosion went right by LCROSS and LRO, and we could detect particles of ice that came out from that surface that blew up. Pretty cool, huh? We got to blow up something on the moon from space. Whew, so we covered a lot in about 25 minutes. Can I take any questions from the boys and girls in the audience? Nobody has any questions for me. Yes? Why do things fall off the sun? Well, things don't really fall off the sun because the sun's a big ball of burning gas. It's a big ball of burning gas. So there's explosions. Like, have you ever helped mom or grandma with making spaghetti sauce? Have you ever seen a big pot of spaghetti sauce and start boiling out of control? And what kind of mess does it make? Because it just goes everywhere, all over the stove, right? Smoke, there's smoke, but then there's those explosions because there's so much heat in that pot and it boils and boils and then it has to release that energy. Well, that's what's happening on the sun. Things aren't falling off. It's because the sun has to release energy, just like that big pot of spaghetti sauce getting a little too hot. Another question.
Well, sun has gas like Jupiter.
It does. It has a lot of gases. There are similar, but Jupiter is not as hot as the sun, is it? No. All right, any other questions?
Is Wally going to go anyplace else?
Well, that would not be NASA's determination now. So yes, we were very fortunate, but we were told specifically one of the many rules that were given to us using Wall-E is that he was not allowed to roll along the surface of the moon. Because in the movie, he's never on the moon. He was allowed to float in space if we wanted to do that, but they didn't provide us really an animation to do that. That's right, he did, absolutely, yes.
Would it, in future versions of this, would Wall-E have like any complete interaction, like where the student says, you know, is this X, Y, and Z?
We didn't get that custom animation. We didn't have the time to do it, nor would Pixar take the time to do it without us if we wanted to pay them to do it. So instead, we would like to move in that effort. The problem is with animation is that I would have to have a whole series of responses because you never know what the kids are going to say, as we've just well learned. Are you thinking of? Have you been to Epcot? Have you seen the sea turtle? What's his name from? What's the turtle's name? Crush. Crush interacts with the kids, but you know that's actually I don't want to spoil it for the kids. Sorry.
That's very kind.
But the teacher that babysitting today, so the teacher is usually online with them, correct?
Yes, on the other side of the camera. So there's a camera in their room and a camera in my studio.
Okay. But could her voice be like laid into Wall-E so she could answer them and they would think that Wall-E?
we could certainly, it's instant interactivity. So anything that's spoken across is just like on the telephone. But for me to get the correct response out of Wall-E would have required a lot more work and hours and hours and hours of animations. So, yes.
Wonderful format. I'm wondering about the kind of the reach of live teleconferencing
Right.
in schools. I mean, how broad, how many, I mean, can you reach all 50 states? How many schools do you reach per year?
A lot. We have reached over the several 100,000 mark. And they become more and more because the schools are now investing into the technology. We often are asked, well, it's so expensive. And we said, well, how much does it cost for a field trip that you just had to cancel because you didn't have the money? It's about $5,000, $6,000 to invest in the equipment. And then you can connect to NASA for free. You can connect to libraries across the country. A Library of Congress, I believe, has video conferencing, museums, zoos. And so it's a worthwhile investment in that technology and it helps with making it more of a virtual field trip. Gives teachers opportunities to take their kids on a field trip without having to actually leave the classroom. But yes, our users is exponentially growing because more and more schools. I would not have said that 6 years ago, 7 years ago when we started. It was very limited population, but video conferencing is becoming very, very real. And in fact, we've actually had to step back. Because even now more schools are just doing webcasting, would like to just, in addition, do webcasting. And they want this kind of content through Skype. And you can't do this through Skype. So
And the school districts now have the connectivity to be able to pull this off. I mean, from
absolutely.
a technical standpoint,
This
tends to work for you.
This is just an IP address.
Right.
You just dial an IP address and you're in, as long as your school district's firewalls are down.
Presenters do. I mean, I can't imagine you do
We
all
have, no. There's a presenter, there is a DLN studio devoted just to video conferencing at every NASA center. So there's 10 across the country, and each studio has 1 or 2 presenters. Our presenters are blocked. They do more teaching in a day than a normal teacher does because we don't get study hall, we don't get free periods. This is our bread and butter, so we're constantly going and going. And we can have, I could be talking to kindergartners at 9 o'clock, and at 10 o'clock I have to switch gears and talk to 8th graders.
So school districts know about you, obviously, because
Through means like this and going to conferences, and NASA, of course, has its own set of educational specialists that go out to the schools and school districts and lets them know about this free material. Your tax dollars at work. It's all free. All right, well, boys and girls, would you like to have Wally come out one more time before we... Okay. Wally, why don't you come out? Oh, don't be shy. Is he going to come? Oh, there we go. Thank you, sir. Well, everybody, thank you very much for your attention. I hope you get to go back to your friends and tell them all that you learned today. Okay, and one more plug for the moon. If you guys really want to learn more about the moon, I'd like to introduce Andrea Jones. That's going to tell you a little about a big effort of NASA's part.
So I work with the Lunar Reconnaissance orbiter, and we're entering extended missions. So we're not finishing up. We're extending the lifetime. And I also work on a program called International Observe the Moon Night. We had over 500,000 people participate last year in 50 countries around the world, and we're going on and doing more and just getting people out to learn about and look at the moon. We are hosting an event at Goddard Space Flight Center on October 8th from 7 to 10 p.m. and it's all about connecting science to art and science to culture. So we have impact paintings and Oreo phases of the moon, and also Navajo Nation members coming to talk about their interpretation of the moon and what it means to them, and NASA scientists talking about what it means to them. So I can tell you lots more information, lots of other activities and speakers and things like that are going on. Again, October 8th, 7 to 10 p.m. It's a Saturday, and I'll be sitting outside if you'd like to hear more about it, and we also have a flyer in case you want to learn more. Thanks.
And I just want to make also a plug, and I'm going to show you the website. From Goddard Space Flight Center, we have something called the Scientific Visualization Studio. If any of you are homeschool educators or work with educators, this is an awesome place to find multimedia resources. Not just these lesson objects that I just explained to you today, but visualizations. Does anybody know what the difference between a visualization is versus an animation? Yeah, you want to take a try at that one? What?
I think a visualization is like something alive, and then a virtualization is maybe something like
You're getting there. Visualizations are animations, but using real data. So when imagery or when data comes off the satellite, we have specialists, mathematicians / graphic artists. Again, you can be a graphic artist and work for NASA, that can visualize, say, the chlorophyll levels of our oceans. And so all these resources are here at svs.nasa.gov. It is free. You can just type in your a vocabulary term or something you're looking for, and it'll provide you with links, and you can download any version you want. As you can see it, for example, here, you can download MPEG-4s, MPEG-1s, WAV format, any version you need. All right. Well, thank you very much for your attention today. If you have any questions, I'll hang around.
This has been a presentation of the Library of Congress. Visit us at loc.gov.